Good morning, friends. Today we are going to explore a very interesting concept in population genetics. In previous lecture also, I have discussed this topic, the inbreeding coefficient, and how it is calculated using the another method. In previous video, we use the pedigree method, but in this case, we will use co-ancestor method. This concept helps us understand the probability of two alleles in an individual being identical by descent, which means that they have come from a common ancestor. If I talk about in simple terms, inbreeding refers to the mating of individuals who are related to each other. The more related the individual, the higher the chances that offspring may inherit the same gene from the shared ancestor. This is where the inbreeding coefficient comes into play, and it gives us a numerical value to measure this probability. Now in this lecture we will using the co-ancestor method to compute this coefficient. This method is based on the tracing back the family tree of the individual and identifying any common ancestors. From these common ancestors, we can calculate the likelihood that two genes, one from each parent, have come from the same ancestral source. And applying the probability theory, we can systematically determine the level of inbreeding within a population. So we will discuss all the example which we have did in pedigree methods. Now we will find out the coefficient of inbreeding using co-ancestor method. So first example is find the coefficient of inbreeding FF. I want to find the coefficient of inbreeding for this individual using co-ancestor method. So F, actually I want to compute F of F, which is the probability or the relationship between D and E, because D and E are the parents of F. Now this D is further the offspring of B and C. So I substitute B and C here. Similarly, E is also have two parents C and B. So I write like this. So phi DE can be written as phi BC comma BC. Now there are four possible ways. Means that the genes are identical by descent. Means if B, 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 C, C, B and C, C. So this can be written as 1 by 4 because all four possibilities are there. So it is phi BB plus phi CC plus twice the phi BC. Now phi BB, this B has no further information of his parents, and C has further two parents. C has two parents B and A, and BC can further be divided into its parents like this. So this can be written as the phi BB. Since we have no information of further parents of B, so it is given by 1 plus FB by 2, and C has two parents A and B. So each C is replaced with its parents AB, and B has no parents, so it is as it is, but C has parent A and B, so it can be written as AB. And if I further simplify it, then this can be written as, since the inbreeding coefficient of FB is 0 because the information of parents of B is not available, so inbreeding coefficient is 0. That's why this becomes 1 by 2 plus Again, four possible ways are there. It is 1 by 4 phi AA plus phi BB plus twice the phi AB plus 2 times, since two possibilities are there, BA and BB. So it is 1 by 2 phi BB plus phi AB. And if you further simplify it, it is 1 by 4, 1 by 2. Now phi AA can be written as 1 plus FA by 2. Phi BB can be written as 1 plus FB by 2. And AB, pi of AB, there is no common ancestor of these two, so it is 0. Then phi BB, again it is 1 plus FB by 2, and phi AB is again 0. So if I substitute the values here, I will get 1 by 4, 1 by 2, 1 by 4. Now this is again 0, f of a, inbreeding coefficient of a is 0, inbreeding coefficient of b is 0, inbreeding coefficient of b is 0. So I am just substituting this, so this becomes 1 by 2, this is again 1 by 2 plus 0 plus 1 by 2 plus 0. And if I simplify it, so this gives me 1 by 2 plus 1 by 4 into 1 by 2, it is 1 by 8. If you simplify it, this is 1 plus 1 by 2. I just multiply all these things. So it is 1 by 4 multiplied by 1 by 2, it is 1 by 8. 1 by 4 multiplied by 1 by 2, it is 1 by 8 plus 1 by 2. And on further simplification, if I take LCM, 8 is my LCM. So 4 plus 1 plus 1 plus 4. So it is 1 by 4 into 10 by 8. So this is 2 and this is 5. So it is 5 by 16. Right. Now we will use another pedigree. For the given pedigree, find the inbreeding coefficient of X here. Then how you will proceed? We will find out f of X. F of X, X has two parents B and E. So I can write fx as phi BE. Now the B, we have no information about B's parent, but we have information about the parent of E. It is A and D. So E is splitted into B into DA. Now using the probability law, it is given by half phi BD plus phi BA. Now you will see A and B are two parents and we don't know the parents of A and B. So this term will becomes 0. And we have left only with 1 by 2 phi of BD. So actually we are finding out the value of this term. Means it is 1 by 2 phi BD minus 0 and it is half phi BD, which can be further. Now B has no information of his parents, but D has two parents A and B, so D is further splitted into A and B. Now again apply the same formula here. You will get 1 by 2 this one and phi AB plus phi BB. Now again phi AB, this is 0, and phi BB by definition is given by 1 plus FB by 2. But f of B, the inbreeding coefficient of B is 0 because we have no information about his parents. So if I substitute this value here, so I will get 1 by 2, 1 by 2 multiplied by 1 by 2, it is 1 by 4. So 1 by 8 is the coefficient of inbreeding. Then another, find the inbreeding coefficient of F by co-ancestor method for a given pedigree. My pedigree is this. I want to find out the inbreeding coefficient of this F. Now, to start with, F has two parents. One is E and other is A. So I will find out F of F by say phi EA like this. So it is AE or EA. Now E has two parents B and D, but we have no information of the parents of A. So E is further splitted into two parents, that is B and D. So this can be written as phi A into BD. So using the law of probability, this can be written as phi AB plus phi AD. Now, and suppose this is equation number 1. I will separately compute phi AB and phi AD. So first of all, I will compute phi AB. So now phi AB is, since we have no information about the parent of A, but B has two parents H and A. So I substitute here H and A. Again apply the formula. Phi, it is phi AH plus phi AA. Now this phi AA by definition, it is given by 1 plus f of A by 2. So I just substitute this, and AH, since they are unrelated, that's why the correlation between these two is 0, and this can be written as 1 plus FA by 2. Now we have no information about the parents of A, so f of A will be equal to 0. I substitute 0 here. So I will get 1 by 4. Now I will take second term, phi AD. Now phi AD, since A has no information about his parents, but D has two parents C and G. So I substitute C and G here. So using the probability is half phi AC plus phi AG. Now A and G, they are unrelated. It means phi AG will be equal to 0, and phi AC, we have to compute this. So this is equal to half of phi AC. Now A, C has further two parents A and H. So I substitute here 1 by half phi A into AH, and this can be given as half phi AA plus phi AH. Right? Now this can be find out, say 1 plus FA by 2 and AH, both are unrelated, so this becomes 0. So substitute these value, it is half 1 by 2, 1 plus FA of this plus 0, and on simplification it is half 1 by 2 multiplied by 1 by 2, it is 1 by 8. Now I have the value of phi AB and phi AD. So substitute these value in equation 1. What we will get? F of F is half phi AB is 1 by 4 plus phi AD is 1 by 8. So on simplification, I'll get it is 3 by 60. Let us do one more example. Find the inbreeding coefficient of F by co-ancestor method for a given pedigree like this. I want to find out the coefficient of inbreeding of this individual F. Now f has two parents, means I want to find out f of f. F has two parents, this is D and E. So let us start with D and E. Now D has further two parents, C and B. C is the parent of D and B is also a parent of D. So this can be, and E has two parents again, C and B. So phi DE can be written as phi CB, phi CB. And this can be further written as 1 by 4 phi CC plus phi BB plus 2 times phi AB. Now we know that phi CC will be equal to 1 plus FC by 2 and phi BB can be written as 1 plus FB by 2. And since FC FB by 2. So this is my equation number 1. Now phi CC is as usual, it is 0, so it is half, it is again half. So now phi CC is half 1 plus FC and this is 0, so it is 1 by 2. Similarly, phi BB is half 1 plus FB, it is again 1 by 2. Now, what about phi AB? So phi AB, since C has AB, it is wrong. This is CB, this is BC actually. This is phi BC. So this is phi BC, phi BC. Now this can be written as B and C has two parents, say A and B. Now it is all right. So this can be further written as half phi AB plus phi BB. As usual, the value of phi BB is half. You can substitute here. So it is, and phi AB, they are unrelated. That's why the phi AB is 0. So 0 plus 1 plus FB. FB is again 0. So it is half. So it is 1 by 4. And if I substitute the values of phi BC, phi CC, phi BB in 1, I'll get f of f as 1 by 4. Half is the value of phi CC, half is the value of phi BB, and 2 times the 1 by 4 is the value of twice BC. If I substitute this and simplify it, I will get 3 by 8. This is my coefficient of inbreeding. So you can find out the coefficient of inbreeding using co-ancestor method for any pedigree. Let us do one more example. So find the coefficient of inbreeding Fz for the following pedigree using co-ancestor methods. My pedigree is this. I am interested in finding out the coefficient of inbreeding of this Z, and it is bit a complicated pedigree. So I want to find out f of Z, and it is nothing but it is phi ys, and we will further split this ys in many. So let us start with this. So phi fz is equal to, I am using phi instead r. It is correlation between y, s and y. S has further two parent A and B, and Y has further two parents C and D. So this can be written as R A into B, C into D. Then it is given as 1 by 4 RAC, RAD plus RBC plus RBD. Now we will compute these terms separately and put it in equation 1. Now let us start with RAC. So RAC A and C. The parent of A is X, but another parent I don't know. So I put it as say O. Similarly, C has one parent X and other parent can be put at O. So R AC can be written as XO XO, and it is given by 1 by 4 RXX plus RXO plus RXO plus ROO. We have no information about these. So these are all are 0. But Rxx is 1 by 2, 1 plus f of x. So it is half. So it is half, it gives 1 by 8. Similarly, RAD, how you can find out? AD, A and D. Same, one parent of A is X and other I assumed it as O. Similarly, one parent of D is X, other is assumed at O. So as we did in previous case, the RAD will be equal to 1 by 4 RXX, RXO and ROO, and on simplification it is 1 by 8. Similarly, RBC can also be written like that, and it is 1 by 4 RXS, RXO, RXO plus ROO, and its probability comes out to be equal to 1 by 8. And exactly on the similar manner, RBD is also 1 by 8, like this. Now put all these value in equation number 1. So it is 1 by 4, 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8. It is 1 by 2. So 1 by 4 into 1 by 2, it is 1 by 8. So these are the few examples in which we have computed the coefficient of inbreeding using a co-ancestor method. It is quite simple and easy to operate, but you have to keep trace of the parents properly. Also, you have to uh, consider such as if two parents are unrelated, say A and B are unrelated, then their correlation between these two is 0. And correlation between parent and itself is 1 plus say f of x by 2. So as usual, these are the two main formulae which I have used in these examples. I think you should understood it properly. If some queries are there, please let me know. Thank you. Thank you very much.